This is the screencast for section 4.7, example 3. We're going to work with inverse cosine and inverse tangent. Very similar to the screencast for example 1. I've put up here the domain and range of the original cosine and tangent functions. Of course, we have narrowed down the domain to make both the original cosine and the original tangent function 1-to-1, so that the inverse will be a function. Feel free to pause this screen and take a closer look at the work I've done to go from the original cosine to inverse cosine or original tangent to inverse tangent. Also make sure to note that tangent range will also be negative pi over 2 to pi over 2, just like sine, although not including. But cosine is going to go from 0 to pi. So for the cosine function, inverse cosine function, we are only dealing with angles in quadrants 1 and 2. If we dealt with angles in quadrants 1 and 4, for cosine, both those quadrants have positive angles, so we wouldn't get to deal with any negatives. That's why we have to use quadrants 1 and 2. Now moving on to example 3. Very similar to example 1, it's asking to evaluate these expressions without a calculator. So in part A, the inverse cosine of negative square root 2 over 2. Well, I know the cosine of pi over 4 is positive square root 2 over 2. I need negative square root 2 over 2. If I went into quadrant 4, again, cosine would still be positive. Inverse cosine's range is quadrants 1 and 2, from 0 to pi. So I'm actually going to look at 3 pi over 4, land in quadrant 2, and be negative square root 2 over 2 on the unit circle, which tells me then that the inverse cosine of negative square root 2 over 2 is 3 pi over 4. Now a little trickier, I told you about the unit circle, it's going to come back. The tangent of some angle is square root 3. Well, if you remember, the tangent of pi over 3 is square root 3. The sine of pi over 3 is square root 3 over 2. The cosine of pi over 3 is 1/2. Square root 3 over 2 divided by 1/2 is square root 3. So because the tangent of pi over 3 is square root 3, the inverse tangent of square root 3 is pi over 3. Part C is a little bit more complicated than the other ones because this is asking you first, again starting on the inside, work your way out, to take the cosine of negative 1.1. Well, I know that negative 1.1 is an angle. I know that because we take the cosine of angles. We take the inverse cosine to find angles, to output angles. So I'm taking the cosine of an angle, negative 1.1. So I drew that angle down here, negative 1.1, and I don't know, I've got its cosine, let's call it Q. So now I'm trying to find the inverse cosine of Q. Well, I can't find an inverse cosine of a negative angle, but I know from reference triangles that if I find the angle positive 1.1 up here, they will have the same cosine value because they're both positive. The cosine of negative 1.1 and the cosine of positive 1.1 will have the same value because they're both on the right side of the x-axis, of the y-axis, and therefore will both be a positive value with the same reference angle and therefore same proportions. So if I call the cosine of angle negative 1.1 Q, and now I'm trying to find the angle whose cosine is Q, but between 0 and pi, that's going to be positive 1.1. So I'm going to make my final answer here 1.1. Now over here for your now try problems. In examples 1 through 12, it says find the exact value. The inverse cosine of 1/2. Well, I know the cosine of pi over 3 is 1/2. Therefore, the inverse cosine of 1/2 is pi over 3. The inverse tangent of negative 1. Well, I know the tangent of pi over 4 is positive 1, but I want negative 1. So I'm going to look at quadrant 4 instead for inverse tangent. I know the tangent of negative pi over 4, which on the unit circle, negative pi over 4, the angle will land in quadrant 4. The tangent of that is negative 1. So therefore, the inverse tangent of negative 1 is negative pi over 4.